Okay, hi everyone. Today in this video we are going to do some problems on control system. The topic here is block diagram SFG, that is signal flow graph and all. The PDF will be available in the Telegram group, the link to which will be given down in the description box, and also the link to my Facebook page as well as Instagram will also be given down in the description box. So there I will be sharing notes, formulas and frequent updates on when these videos are coming. So without further ado, we'll start with the first question. The transfer function of the system shown in the figure is, so we have to find out the transfer function of the given figure. So for that we have a formula known as Mason's gain formula. We are going to use this gain formula for all the questions in this session. Okay, so the transfer function is equal to, using Mason's gain formula, is equal to sigma k is equal to 1 to I pk delta k whole divided by delta. Okay, so what is delta? Delta is equal to 1 minus sigma individual loop gain plus sigma sum of gain product of two non-touching loop minus sum of gain product of three non-touching loop plus sum of gain product of four non-touching loop, and plus minus it will go in the alternate form. So we have to remember this formula, and pk is the forward gain path. Okay, so forward gain path, for what is this forward path? The forward path is the path from input to output. It is only going in the forward direction. Okay, do not take anything in the backward direction, then it will become a loop. Okay, so instead of that we'll just move forward from R of S to C of S. That is the forward path. So whatever path is there that is linking between, in the forward direction, linking between R of S and C of S, then it is a forward path. For example, we can see how many forward paths are there in this form, this block diagram. As you can see, we can travel from R of S, A, and then move towards B and then to C. That is one forward path, and the other one is either we can go through this side or A, then we can go through this line, okay, to C. So there are two forward paths. So the first forward path I wrote it as P1, and the gain is actually A into B, right? And the second forward path is equal to what? Second forward path is equal to A into 1. Okay, and now we have to see if in the question it is given pk into delta k, right? So delta k is 1 minus sigma individual loop gain plus sigma sum of a gain product of, and so on. So for the forward path we will see if there is any loop in it. If there is any non-touching loop in this forward path. So as you can see, how many loops are there? Loop means it should return from, if I am starting from here, and if by any means I am coming towards this point again, then that path is known as the loop, and the starting and the ending point should be the same. Then that point is known as, that path is known as the loop. So as you can see, what is a loop here? You can travel from it. I am starting from here, A, B, and again travel from here and come back to this point, right? So that is one loop, and the other loop is, we can see, come over here, then travel towards here, and then use this path and come. So there are two loops. Both of these loops are touching the forward path. Okay, first forward path is this one. It is touching this loop, right? Touching the forward path, right? And the second path, we can see this is A, like this, that is also touching our forward path. So there is no non-touching loop over here. So if I write the transfer function, it will look like this. And what is delta? Delta is equal to 1 minus individual loop gain, sigma of individual loop gain. So first loop gain is A, B, and then coming here, right? So that is equal to A, B, negative, okay? There is negative here, so I am taking minus AB, okay? And then the other loop is A into 1, again minus 1, so that is minus 1. So open in the bracket, I get 1 plus A plus AB, okay? And now I'll write the transfer function. Transfer function is equal to P1 delta 1 plus P2 delta 2 divided by delta. Here delta 1 is equal to 1, delta 2 is equal to 1 as well, because there are no non-touching loops over here, okay? So I can write P1, instead of P1 I can write AB plus A whole divided by 1 plus A plus AB. So this is how we are going to find out the transfer function using Mason's formula. Okay, we'll do some more questions and you'll be familiar with it. Now let's do the next question. The transfer function relating to E and R. E is here, okay? So the transfer function relating to E and R. So we should in a transfer function relating to E and R is asked here, okay? So the input is R here, the output is E here. So we have to find out the number of a forward path. How many forward paths are there? One forward path, right? We are not taking these paths because it is taken in the backward direction. We can take it. So only one forward path is there. What is the gain and on that path? No gain is there, that is equal to 1. So P1 is equal to 1, okay? And we will see how many loops are here. This loop, that is starting from here, G2, then H, then again coming here. The next loop is G1, H, okay? There are two loops and these two loops are connected to our forward path. So we can write our delta K, delta 1 equal to 1 only, okay? So now writing the transfer equation is equal to Pk delta K divided by delta. What is delta? Delta is equal to 1 minus sum of individual loop gain. What is individual loop gain? First loop is G2H. Negative is there, that is minus G2H. And the second loop is G1 into minus H, that is also G1H, okay? So 1 plus G2H plus G1H, and we have to see if these two loops are non-touching to each other, because the according to Mason's gain formula, we have written that 1 minus sum of individual loop gain plus sum of gain product of two non-touching loops. So every time please see if these loops, all the loops here are non-touching or not. That means it shouldn't have a common node. Okay, as you can see, these two are starting from the same node, right? And so we can't say that these loops are non-touching. If they don't have a common node, then they are non-touching loop, okay? So the transfer function equal to P1 is equal to 1 whole divided by delta is equal to delta 1 is equal to 1 only. So 1 into 1, that is equal to 1 divided by 1 plus G2H plus G1H. So this is the transfer function. Okay, and now let's do the next question. The closed loop gain of the system sketched below is, that is, we have to find out the transfer function only. So what is a closed loop gain? G divided by 1 plus GH plus, if it is a positive, negative feedback, minus, that is 1 minus G divided by 1 minus GH if it is a positive feedback. This happens because in negative feedback our gain, overall gain is reduced, right? If it has to be reduced, then denominator should be greater. That is why it is plus. Okay, 1 plus GH is greater than 1 minus GH. But when it comes to positive feedback, what happens is the overall gain will increase. So the denominator should be less than compared to negative feedback. So 1 plus GH for negative feedback and 1 minus GH for positive feedback. Please don't forget it. Okay. And if it is plus here, then it is means that it is positive feedback. If it is negative here, then it means that it is negative feedback. Okay, so I can write G divided by 1. This is positive feedback, right? So the overall transfer function is equal to G divided by 1 minus GH. So what is G here? Minus 5 divided by 1 minus of, instead of GH we write minus 5 into H is 1 by 4. That is equal to minus 5 divided by 1 plus 5 by 4. We'll get 20 divided by 9. Okay, so this is the answer. Now let's do the next question. Okay, what is the overall transfer function of the block diagram given above? We have to find out the overall transfer function. That is, first of all, we have to find out how many forward paths are there, then how many individual loops are there, how many non-touching loops are there, so and so. Okay, so first of all, we'll see how many forward paths are there. We'll start from R of S and end at C of S and see which path, how many paths are there that are linking from R of S to C of S. So we can start from here, that is G of S into G1 into G2. So this is G2, right? So G1 into G2 is one forward path. I can write P1 is equal to G1 G2. And the other forward path we'll see travel from here. Please have a look at the arrow. We can't go like this, okay, because this is in the opposite direction. Travel from here, G3, then come here, and ultimately we will reach C of S. Please take the forward path in the forward direction only. It can't be taken in the backward direction. So P2 is equal to G3 G2. Okay. And now we will see how many loops are there. Loop means it should start from one point and end at that point only. That path is known as a loop. We'll see, we'll start from here, G2 H1. That is a one loop. Okay. Is there any other loop? No, there is no other loop that is starting from one point and ending at one point. So these two loops, this loop, the first forward path is this, right? It is connected to our forward path. The loop is connected to a forward path, so no non-touching loop are there. And this one also is connected. Okay. So we can write delta 1 equal to delta 2 is equal to 1 itself. And what is delta k? Delta k is equal to 1 minus, overall delta. Delta is equal to 1 minus sum of individual loop gain. Individual loop gain is equal to G2 into H1. It is negative. You should take the sign minus, okay? And that is equal to 1 plus G2 H1. I have had taken, okay, it's okay. 1 plus G2 H1. And we'll see the transfer function. Transfer function is equal to P1 plus P2 divided by delta. That is G1 G2 plus G3 G2 divided by 1 plus G2 H1. So this is the answer. Okay. And now let's see the next question. Find out the delta of the system, that is 1 minus sigma individual loop gain plus sum of a gain product of 2 non-touching loop minus sum of gain product of 3 non-touching loop, and so on. So first of all, I am going to find out what the individual loop gains. So this is a loop, right? G of S, and then coming back, that is negative G of S, because it is negative here. Please take the sign. And coming to this particular thing, we will see G of S and coming back, but here it is plus, so it will be G of S only. And we'll see if any other loops are there. Okay, travel from here, R of S, G of S, coming over here, travel towards here, then from here we'll go back to RFS. So even if the loop looks complicated, we have to take it. Okay, every point that is whose starting and ending point are the same, that is every path whose starting and ending point are the same are a loop. Please take it even though it looks complicated. Okay, so that is, we start from here, come here, and then went back to this. That is it is also a loop. That is g of s, again g of s, and coming back. Okay, so that is g of s into g of s. It is positive, so we don't have to take a negative. So g of s into g of s, that is g of s the whole square. So that is the individual loop again. And the other one, we have to see if there are two non-touching loop and three non-touching loop, everything. So this loop, see this loop, this is one loop, right? This is one loop and this is another loop. These two are non-touching, they don't have any common nodes. Okay, so that means g of s, that is minus g of s and plus g of s, are non-touching, two non-touching loops. What we have to do is, we have to take its product, that is g of s into g of s, which is equal to minus g square s. And you can see if there are three non-touching loop. Is there three non-touching loop? No, there is no three non-touching loop. That is the loops which are independent of each other. Okay, the third loop is actually connected to both the nodes. There are common nodes between loop 1 and loop 3 and loop 2 and loop 3. So we can't say that any and the other two non-touching loop or three non-touching loop are there. So we'll stop here and write the delta. Delta is equal to 1 minus individual loop again, that is minus g of s plus g of s plus gs square, again plus two non-touching loop at a time, right? Sum of product of two non-touching loop. And I'll open the bracket. Okay, I can cut it out, right? G square s minus g square s, which is equal to 1 minus 2 g square s. So that is the answer. Okay, now let's do the next question. The transfer function between y2 and y1 in the figure is. So what is the formula? Pk into delta k divided by delta. So the one forward path is y1 to y2, that is A, and other forward path is B. Okay, any non-touching loop here? This is the only loop that is touching this forward path, so we can't take it. And what is delta? Delta is equal to 1 minus individual loop again. Individual loop gain is C. Okay, 1 minus C, and now that is only loop here. So the transfer function becomes A plus B divided by 1 minus C. So that's all. That's very simple. Okay, now let's do the next question. Okay, now the question is the sensitivity of the following system, closed loop system, to variation on parameter k is approximately. Okay, that is the change in transfer function with respect to the parameter k is asked here. So that is SMK. The formula for sensitivity is dm divided by dk into k divided by m. That is change in transfer function. M is the transfer function here, m with respect to k into k divided by m. Okay, so first of all I'll find out the transfer function here. So the transfer function is equal to, what is the forward path here? K divided by, or we can use the other thing, that is g divided by 1 plus gh. Okay, so g is actually 10 plus 1 divided by 1. So this becomes 1 plus k into kt divided by 10s plus 1, which is equal to k divided by 10s plus 1 divided by 10s plus 1 plus k kt divided by 10s plus 1, and we'll get k divided by k kt plus 10s. Okay, 10s plus 1, right? Okay, that is our m, and now we have to find out dm divided by dk, that is change in m with respect to k, that is k kt plus 10s plus 1 into 1 minus k into 0, sorry, kt plus 0 divided by k kt plus 10s plus 1 the whole square. Open in the bracket, we get k kt plus 10s plus 1 minus k kt divided by k kt plus 10s plus 1 the whole square. We'll get 10s plus 1 divided by 10s plus 1 plus kkt. Okay, so we got dm divided by dk, and now k divided by, and we are going to multiply that with k divided by m. What is k? K will write it as it is, and m is actually equal to k divided by k kt plus 10s plus 1. Okay, and solving, this is actually square, right? So solving, we get 10s plus 1 divided by 10s plus 1 plus k kt. Okay, and now we have to do s is equal to 1j and kt is equal to 99, and I'm going to put that over here. Okay, I'll write it over here. So smk is equal to 10 into j 1 plus 1 whole divided by 10 into j1. Oh, I can write 10j, right? 10j plus k plus 1 plus kkf is 99. So we'll get 1 plus 10j divided by 100 plus 10j. And we'll find out the modulus. That is 100 plus 1 divided by 10 raised to 4 plus 100. And we'll get the answer equal to 0.1. Okay, so that is the sensitivity. Now we'll do the next question. What is the transfer function of the system shown in the figure? So what is the forward path? First forward path is, this is the input and this is the output. So first forward path is this one, right? That is equal to P1 is equal to 1. And what is P2? Travel from here, we'll go and ultimately we should reach our C of S. Okay, so we'll get minus A into B into minus C, that is equal to ABC. So first forward path gain is 1 and the second forward path gain is ABC. Okay, and is there now non-touching loops? We'll find out loop gains. First loop is A into G, minus AG, and next one is minus TC, and A, B, C, no, there's no other loops, right? And two non-touching loops are there. This AG and TC, as you can see, these are the two nodes connecting this loop. These are the two nodes connecting this loop. They don't have a common node, so they are not touching to each other. So we have to find out the product of non-touching loops, that is AG into TC. Negative and negative cancel out, we will get GATC. Okay, and now we have to find out the transfer function. Transfer function is equal to P1 plus P2. P2 is ABC whole divided by 1 minus individual loop gain, that is AG minus TC plus sum of two non-touching loop. That is, after opening the bracket, we will get 1 plus ABC divided by 1 plus AG plus TC plus GATC. Okay, now let's do the next question. The signal flow graph shown in the figure, transfer function C of S divided by R of S. Okay, now first of all we have to find out the forward path. That is one is A, B, C. Okay, A, B, C. The other forward path we will see can go from here to here, right? The other forward path is 1. And is there any other forward path? No, right? And delta 1, is there any non-touching loop? We can see there are loops in this figure. This is one loop, this is another loop, and this is another loop. These three loops, and this one is also another loop. Okay, all these loops are connected to our forward path A, B, C. Okay, so I can write that here there is any non-touching loop in this particular forward path, and see the other forward path. This is the other forward path. Okay, 1, 2. So delta 1 is equal to 1. There is no non-touching loop. And what is delta 2? Is there a non-touching loop? This is a forward path. Okay, this is connected to this one, which have a common node, that is so this loop is connected. But see this node, this loop, minus B loop. This loop has one node here and one node here, but this loop, this forward path has one node here, one node here. That is, there is no common node. That means this forward path and this loop are not touching to each other. So I can write delta 2 is equal to 1 minus of minus B. The loop again is minus B. Okay, B into minus 1. Okay, so 1 plus B. Okay, got it. And now individual loop again. What are the individual loop again? L1. First one is minus A. L2 is minus B. L3 is minus C, and the other one is minus G. Okay. And is there any two non-touching loops over here? Okay, there is another loop too. A, B, C, G, right? Start from here and end here. So A, B, C, G, negative, because G is minus G. So these are the individual loops, and we have to find out if there are non-touching loops. See, this loop and this loop are non-touching loop because there are no common nodes. So product of two non-touching loops, which is equal to A and C, right? Minus A and minus C, that is AC. And the other loops are, these are all connected. Okay, this loop minus G and B are not connected, right? So the other one is minus G and minus B, that is GB. Okay, that's it. And now we'll write the Mason's gain equation, which is equal to P1 delta 1 plus P2 delta 2 divided by delta, which is equal to P1 is A, B, C plus P2 is 1 into delta 2. Delta 2 is 1 plus B. Okay, the whole divided by 1 minus individual loop gains. Okay, there is one more loop here. I forgot to write SL6. Start from here, 1 minus 1 into minus 1 into minus 1. Okay, so that is equal to minus 1. So alpha minus A minus B, individual loop gains, minus C minus G minus A, B, C, G minus 1 plus sum of product of two non-touching loops. So one is AC plus GB. Okay, I'll get A, B, C plus 1 plus B divided by 1 plus A plus B plus C plus G plus A, B, C, G plus 1 plus AC plus GB. 1 plus 1 we'll get 2. Okay, so this is the answer. Okay, now let's do the next question. Okay, the system is shown in the figure. Its gain is, that is, we have to find out the transfer function only, which is equal to, we will see how many forward paths are there. P1 equal to A, B, C, right? P, C. And the other forward path, P2, will see A, B, C. Okay? This one. Okay, this is another forward path. And we will see if there are any non-touching loops. First loop is B, C, A. Is it touching this forward path? Yes, it is touching this forward path. Is it touching this forward path? Yes, it is touching this forward path. And the other loop is A, B, C. Okay, is it touching this loop, this forward path? Yes, it is touching. Is it touching this forward path? Yes, it is touching. So there are no non-touching loops. So delta 1 is equal to 1 and delta 2 is equal to 1 as well. And now we'll write the individual loop gains, that is B, C, A, B, C, I'll write, and other one A, B, C, but it is negative, please write it A, B, C. Okay, and is there any other loop? Start from here, and okay, so there is another loop too, that is this one, B, C, A. Okay, and now we'll see what is P1 delta 1 plus P2 delta 2. Are they non-touching to each other? This loop, and this loop. No, they are non-touching either because they all have a common node over here. So they are not non-touching to each other, so no need to take that product. Okay, so delta P1 is ABC plus P2 is ABC. Delta 1 and delta 2 are 1, so no need to write it. Divided by 1 minus individual loop gain, that is ABC minus ABC plus ABC that is all. It is 2ABC divided by 1 minus ABC. So this is the answer. Now let's do the last question of the session. The block diagram in the figure can be reduced as a block diagram as shown in figure B. So this is figure A and figure B. The parameters x and y respectively are. As you can see, the output over here is AG plus B. What is the output over here? I'll just write the output according to this one, that is A plus X. This is plus addition, that is A plus X into Y equal to AG plus B. So that is AY plus XY. That is okay, there is B here. Okay. Okay. That is A plus AY plus BXY equal to AG plus B. So comparing, we will get Y is equal to G and XY equal to 1. That is X is equal to 1 divided by G. So X is equal to 1 by G and Y is equal to G. That is the answer. With that, I'll end this video. The PDF will be available in the Telegram group. Please like, share and subscribe to my channel. Thank you and have a nice day.